This is the video for overhaul routines. Here on the left is a routine, and then here on the bottom left is the start of the routine over here. So we're going to go over two routines. First, we're going to start with this one on the left. First, it zeroes out 144 values at the game matrix. Well, it's a 12 by 12 matrix, so it becomes a null matrix. Then it does a reset. That resets all probability distributions. So this is initializing the game matrix and also setting the probability distributions back to the beginning. The next, it sets SG to the game number. That's going to be used for the C down here of the probability distribution. It's going to be the game number. Then it sets equally likely to 20, sets A to 250, then it adds the game number to it. Well, then it's going to go from 250 to 250 plus 99, which is going to be 349. Then it divides that by 1,000. Oh, so that becomes a fraction. Then it sets J to 0. It sets Q to 120. Then it says for I of 0, and down here next I till it gets to 10, one at a time. Well, since it starts at 0 and goes to 10, it's going to go around here 11 times. And this value set to J is going to be increased down here by 13. Well, the rows are 12, so 13 means it's going to move over one to the right each time. It's going to go down the diagonal, that value of J. It's going to be the offset for the diagonal of the matrix. So at first it sets, well, it puts A at the offset 1 past J, 1 to the right of the diagonal. That's the value A we calculated up here. Then it sets the value on the diagonal to 1, and then it subtracts that value of A from it. It's going to make a Markov chain, and this is a transition matrix, so the rows must add up to 1. So it set the diagonal to 1 and then subtracted the one value that it put on that row from it. Then it sets the profit at offset I started at 0, to Q. Then it picks a random number, equally likely. That's what PEC does. Going to put the answer into P. Here is the seed number it uses, and that changes with the game, so that means this is always going to change with the game. And this equally likely we set up to 20 up here. So it's going to pick a value from 0 to 19, equally likely. The next line multiplies that value by 2. So now it's going from 0 to 38. Well, then it adds 950 to it. Now, so that means it could be 950 or it could be 988. Divides it by 1,000. Ah, well, now we know it goes from 0.950 to 0.988. It's going to use that as a multiplier. Down here it says that value of Q, which we set to 120, now is going to be reduced each time it comes around here by this fraction it makes. The profit is going to be reduced each time we go around. Well, then it uses the PEC action again. Again, it's going to get a value between 0 and 19, equally likely. Then it divides that by 1,000. Well, that's going to be a fairly small number. And then it adds that to our value of A. Well, we saw up here how it calculated A. So each time it's going to add a little bit more to it. Then the next time, here's where it adds the 13 to J. Remember, that makes it go down along the diagonal, the offset. Next, I10, one at a time. And then it sets at game matrix plus 132 the value of 1. That's the very last row of the matrix. It's going to place a 1. Well, we're going to quickly look at the matrix it built. Here's an example of it. Here we see that 0.25 being put one position to the right of the diagonal, and that goes down for all these rows down to here, and the last row, though, has a 1 in the very first position. Now we're going to go over the second routine. First starts out by setting F to 400, and over here it uses that offset to store the matrix it's going to build, and in the list called store matrix, and in the list called SS matrix, it's going to be the offset for the steady state matrix. Then it sets G to 24. Well, the first matrix it's going to build is going to be 3 by 3. G is going to be the offset to the last row in that matrix. Well, the first one is 3 by 3, so the last row is down 3, or 2 rows, so it's offset 2 times 12, or 24. And every time it goes around the loop, it's going to add 12 to G down here. So when it's a 4 by 4 matrix, it's going to point to the offset of the fourth row. The last value here, H, is set to 40, and over here it uses H to store the probabilities from the steady state. But when it's in the steady state, all the rows are the same, so it only stores one of the rows into probability. Then it's going to come over here once it's done that, and it's going to say for mg of 3, and that's going to be a 3 by 3 matrix, to mg of 12, it's going to be a 12 by 12 matrix then. Next thing it does is it stores the game matrix, that's the one we built over here, into matrix. Then it fills the 12 values at matrix plus G. Remember, that's the offset to the last row. Fills them all with 0, but then it puts a 1 in the very first position of the last row. Now, when we saw the original one, it was 12 by 12, we saw that's what the last row looked like. It had a 1 in all zeros. The next thing it does is it sets the control register LS to 12. Well, that's the offset change for each row. It needs to know that for this multiply list instruction down here. Then it moves all of matrix, the store matrix, at that offset F. So it's storing every one of these matrices as we make it. The next one moves matrix into hold matrix. Well, it's going to use that down here to multiply. Then it sets NS to 1000 plus mg. Well, remember the first time it's 3, so this will be 1003. The fact that 1000 is added to it means that it's a square matrix, and we can use this multiply list to perform a multiply of one matrix times another. So the 3 in there is just going to be that it's a 3 by 3 matrix. Then it says for I of 1 to next I 12, I'm going to multiply the whole matrix times the whole matrix to get the steady state matrix. But then I'm going to move that steady state matrix to the whole matrix, and then I'm going to go around here 12 times. It's going to raise that matrix to 2 to the 12th power, or 4096 power of the matrix. Then it should reach the steady state, multiplying that many times. So the very next time it says, okay, we're going to store that in SS matrix at offset F. F down here changes by 200, offset 200 we'll say, every time it goes around. So it's saving every one of those steady state matrices. Then it says here it's going to also save in probability plus h the steady state values in the first row. Again, all the rows are the same, so it doesn't have to save all of them. It just says for the probabilities of the first row. Then it says set j to mg. Well, first that will be our 3 up there, but subtract 2 from it. So it's going to become 1. Then it says k equal to our h. Well, that's going to be these probabilities up here. That's where they're offset in probability. So for I of 0 then, to I of j, one at a time, is going to take each one of those probabilities from the steady state and multiply it times the product. Well, actually, that times the profit to get the profit for that particular, in this case, column. But then that just goes for those times that the thing is running the rows. It also has to figure out the cost of it being overhauled. So the next thing it does, it takes the probability of the last row and multiplies it by the overhead cost, and then it adds all of them together to get the answer total cost. And here we see it changing the offsets for our F, G, and H, and then it goes around until the 12th one, and the 12th one is actually going to be the one that we see when the game is starting, this one. Alright, so this is the end of the video on overhaul routines.